Good morning, students. So today we are going to discuss about the last part of the current electricity. That is nothing but potentiometer. The last part, okay, potentiometer. So the previous class we have learned about two important things. One, we have learned about the Kirchhoff's law. After that, we have learned about the applications of the Kirchhoff's law. So today we are going to study about potentiometer. The application we have learned about meter bridge, that is a device, and you are going to do that as a practical. And the second one is potentiometer. This is also there for the practicals. Okay. So two things. One is meter bridge and another one is potentiometer. Meter bridge, there is another one that is otherwise called a slide wire bridge. In the meter bridge, the name meter came from the length of the wire what we are going to use in that case. There, the length of the wire is 100 centimeter. That means equivalent to 1 meter. That is the reason we call it as meter bridge. But potentiometer, we are not using a fixed length, but probably the meter bridge which we have used in our school have the length of 10 meters. How much? The length of 10 meter. Okay. Potentiometer, the name itself explains about the device. Potentiometer is a device which is used to find out the potential difference between any 2 points. Okay, it is used to find out the potential difference between the any 2 points. That is the main important application of this potentiometer. Now, then you can ask, sir, what is the difference between the potentiometer and voltmeter? Voltmeter is also a device which you can able to measure the voltmeter. But 10th standard, you have learned that ammeter and voltmeter. Ammeter must be connected in series. Voltmeter must be connected in parallel. Why ammeter is connected in series? Ammeter is a low resistance device. Does not take current from the source. But voltmeter not like that. Voltmeter is a high resistance device. So it cannot be connected in parallel combination. Suppose if you are connecting a voltmeter in the parallel combination, it will draw maximum current from the source. So after the voltmeter there is no current is available. That means the voltmeter will block the current. That is the reason voltmeter always connected in parallel combination. But potentiometer also measure the potential difference. Voltmeter also measure the potential difference. But here we are using the potentiometer. Potentiometer is a sensitive device than the voltmeter because here we are using a galvanometer. In null deflection method, in the null deflection, the galvanometer does not draw current from the source. That is the reason potentiometer does not draw current from the source. So it shows the real reading. But voltmeter draws a small amount of current for its own function if it is connected in parallel also. So that never shows the correct reading. So if you want to measure the correct reading, we should use a potentiometer. That is the main application of this potentiometer. Okay. So now let us move on to the principle. The main, this is the very important question. Why potentiometer is preferred over voltmeter? Potentiometer is preferred over voltmeter as the potentiometer does not draw current from the source. But voltmeter will draw current from the source. That is the reason we prefer potentiometer. In the laboratory, to measure the potential difference, we used to use a potentiometer. Now, let us see just the construction of the potentiometer. The potentiometer consists of 10 meters of wire. The 10 meters of wire are connected across a wooden table and it has a primary battery. The battery is given here and you can able to find out a variable resistance that you can call it as a rheostat, and there is a key that is connected across here, and these two terminals you can take this as the terminal A and this is a terminal B. Okay, so this is the terminal A and this is the terminal B. Across this terminal only the 10 meters wires are connected. Here you can find out what you can say copper strips, and here the second, and here third, fourth and fifth. Then it is connected here. The next terminal is connected here, then connected here, then connected here, and finally it is connected here. Okay, so this is the procedure, okay, of the, and the terminal across these two terminals, the total length will be how much? 10 meters. Okay, and from the point A there is one more battery. This is called as the secondary circuit or the secondary battery, and here you can find a high resistance. Then you can find a galvanometer. The next terminal of the galvanometer is connected to the jockey J. Okay, this we can say that this is the jockey J. So this is the construction of this potentiometer. Understood now? And the distance from the point A to the point J, that we can call as balancing line. This diagram can also be drawn this way. Okay, here you can find a battery, then a variable resistance, and this is the terminal A, and this we can take it as the terminal B. Across that, this you can take the terminal B. Across here only the 10 meter wire is connected. From the point A there is one more, and you can find a HR, then a galvanometer, and that will be connected J, and this is the balancing length L. Understood now? So this also can be drawn this way. The main difference between the meter bridge and the potentiometer, meter bridge there are only one battery will be used, but here we can able to find out what are two batteries. Okay, you can able to find out two batteries. I think it's clear. Okay, we could able to find out two battery in this. Okay, that is the main difference between the potentiometer and, so this is the similar diagram or equivalent diagram for the given thing. Okay. Okay, so now let us move on to the construction. It will consist of few meters of wire, and you know that there is nothing but 10 meter, across which a battery and a variable resistance RH. This is the battery. Then this is the battery and a variable resistance RH is connected. This forms the primary circuit, and this the remaining thing will be forms the secondary circuit. Here the principle of the potentiometer is nothing but the potential difference across the given conductor is directly proportional to the balancing length. The potential difference across the conductor is directly proportional to balancing length. That means V directly proportional to L. That is the basic principle of the potentiometer. V directly proportional to L. Okay, so now we are going to derive how to derive the potential difference across the conductor can be obtained. Okay, so now you know that the potential here, let us assume that the potential applied across the given conductor is E, or here you can take this is E. Now we are going to take the jockey at the terminal A. Now the galvanometer shows a deflection along the left side. Now just we have to move the jockey from the one end to towards the other end. When the jockey moves from one end to another end, at a particular point we can able to find out the galvanometer shows zero deflection. The galvanometer shows zero deflection. At which point the galvanometer shows zero deflection, that point we have to stop and we have to measure the length. That length we can take it as L. Okay. Now let me take it as R is the, clearly watch here, R is the resistance per unit length. Normally we'll be using R for internal resistance, small r. But here R is the letter which is used to find out the resistance per unit length of the conductor. Resistance per unit length. Okay. So across this length, now the resistance can be taken as the net resistance across the length AL. So across AL, net resistance R can be written as small r into length L. So you can write that as what? R into L. Okay. Now you know the formula for potential difference across the conductor. V is equal to IR. Okay. I is the current flowing through the circuit. Let us assume that. So V can be written as R. Here we take this potential difference as V across here. So V is equal to I into, instead of R I can write this R into L. Here I constant, the small r also constant. So the variable is only the balancing length. So I can write it as V directly proportional to the balancing length. Understand? V directly proportional to the balancing length. So this is the principle of potentiometer. Here I is the current flowing through the potentiometer. R is the resistance per unit length. Both are constant. I constant, R constant. So you can say that V directly proportional to the balancing length L. Understood? V directly proportional to the balancing length L. So this is the principle of the potentiometer. That means the potential difference across the conductor is directly proportional to the balancing length. But here one consideration is there. That means the wire what you have taken, the 10 meter wire, that is made by manganese or Constantine. Again we are using alloy. And why we are using alloy, that importance already we have learned in the meter bridge. For alloy, the temperature coefficient value will be very, very small. The temperature coefficient value is very small means what is the meaning of that? Nada? If the temperature increases, the resistance of the conductor will not vary. That means the variation produced across the given conductor will be negligible. That is the reason we are using what? Nada? Given the manganese wire is used. So these are the important important, what you can say, that the principle of the potentiometer. Now there are two applications. There are two applications for the potentiometer. The first one, okay. So the first application of the potentiometer is we can able to compare the EMF of two cells. We can able to compare or not the EMF of the two cells. The second one, we can able to find out the internal resistance of the cell. So there are two applications for the potentiometer. First, let us discuss about how do you calculate the or how do you compare the how do you compare the EMF of two cells. This also you are going to do as a practical. Okay. So in this case, you can able to find out what now two cells can be connected in the given thing. Okay, how many cells? Two cells. So the circuit diagram. This is the primary circuit. The primary circuit or not, there is no difference. And here again a variable resistance rheostat. If you want, you can put a key over here. And this terminal you can take it as A. This terminal you take it as B. And across the terminal, these wires are copper strips. So again it is connected here, then connected here, then it is connected. Okay. And from the point A you can find, okay, this is the point A. Here you can find what two cells. This is the first cell and this is the second cell. This cell, first cell EMF, let me take it as E1, and the second cell EMF, let me take it as E2. And here you can find what a 3-terminal battery. This you can take it as 1, this is 2, and this is 3. From the 3 you can able to find out a galvanometer G. Before that, if you want, you can put a high resistance HR, and then it is connected here. So when this terminal, the EMF is connected to the terminal 1, the EMF of the second one is connected to the terminal 2. Here you see all the positives are connected together at the point A. If the polarity is wrong, suppose if you are connecting wrong polarity here, the galvanometer shows what not a same side deflection. There are two possibilities for the same side deflection. This is also a board question. What are the causes for the same side deflection? The first one, the polarities are connected wrongly. At the point A, all positive polarities should be connected. Suppose if the polarities are connected wrongly means the galvanometer shows same side deflection. Second one, here we are using a primary battery with the EMF E, and here we are using the two secondary batteries with the EMF E1 and E2. The E must be greater than E1 and E2. The E must be greater than E1 and E2. Then only you will be getting both double side deflection. Suppose either E1 or E2, anyone greater than E means you cannot able to get correct reading. That means the balancing point will not be available across the point, across the length AB. It may available on the side A, or it may available on the side B. So it shows same side deflection. So to avoid that, we should use a primary battery with a EMF greater than the secondary circuit. Okay. So here the first one, let me take it as a Lagrange cell. The second one, let me take it as a Daniell cell. So two primary cells are connected on the secondary circuit. Okay. We are going to compare the EMF of these two cells. So when first let me connect one to the terminal 3. If we connect one to the terminal 3, the point will show one point, that let me take it as J1, and the balancing length we can take it as L1. So according to the principle of potentiometer, I can write it as E is equal to IR into L1. I is the current flowing through the circuit. E1 is equal to IR into L1. Now let me disconnect the first battery and let me connect the second battery to the circuit 3. So now you can get, when the second battery is connected, it may find a new position. That position let me take it as J2. So now you can write, and here the balancing length will be L2. So you can write as E2 is equal to IR into L2. Take this as equation 1 and let me take this as equation 2. Okay, now let us go with equation 1 divided by equation 2. If the equation 1 divided by equation 2 means you will be getting IR L1 divided by IR L2. So both the IR get cancelled. So what will get? E1 by E2 is equal to L1 by L2. You can able to compare the EMF of two cells. Suppose if any one value E2 is known, you can able to find out E1. E1 is known, you can able to find out E2, or you can able to compare both the cells. Okay, the EMF of both the cells can be compared by this is the first practical you are going to do, comparison of EMF by using a potentiometer. Okay, so this is the first application of the given thing. Now let us move on to the second application. The second application of the potentiometer is finding the internal resistance. Okay, finding the internal resistance. We can able to find out the internal resistance of the cell by using potentiometer. That is the second important application. So to find the internal resistance, again the primary circuit will be the same. We can able to get what the primary, and there is a rheostat. Let me take this as RH, and there is a key. This key, let me take it as K1. And these are the two terminals. This point you take it as A, and this point let me take it as B. And we can have so this wire is connected here and again connected. connector, and this will be connected here. Okay, this is the primary circuit, and here the EMF is E. Now let me take the secondary circuit. Here I am going to take a battery, and again see, here we are going to take a battery, and there is a key. That key you can take it as K2, and here a resistance box RP. This we can call as a resistance box, and again this will be connected together, and again we have the high resistance, then galvanometer. It is going to connected over here. This is the jockey shape. First, what you are going to know, first let us see K1 closed, and K2 will be open. Okay, K1 is closed and K2 open. We are going to open the circuit K2, and only K1 is open closed. Okay, sorry, there is a small mistake what I have done. See, this will be connected here. Here only the key K2. Okay, so K2 is open. K2 is open means the external resistance not included in the circuit now. See here, the external resistance not included. Only we have included what not the internal. Okay, so now it shows what reading. That reading, let me take it as J1. That reading I can take it as E1 is equal to, or EMF E is equal to IRL1. You know that the EMF of the cell is independent to the external resistance. We have learned about the potential difference and EMF. EMF means the potential difference across the conductor when the circuit is open. Potential difference means the difference in potential across the circuit when the circuit is closed. So here K2 is open. K2 is open means external resistance not included in the circuit. If the external resistance not included in the circuit means you can able to get the EMF that I can write E is equal to IRL1. Consider this as equation 1. Okay. Now second what you are going to know, K1 comma K2 both are closed. So if both are closed means what not a current will be allowed through the both the circuit. So in this case I can take that as what not a V. That means now the jockey shows some other reading. It may show here. That point let me take it as J2, and that is equivalent to the potential difference, not EMF, because the external resistance included in the circuit. External resistance included in the circuit means that gives the V. V is equal to IRL2. Take this as equation 2. Now you can find out E by V is equal to IRL1 divided by IRL2. So this IR cancel, that is equal to L1 by L2. Okay, now we know the formula. This you take it as equation 3. Now you know the formula for internal resistance. R is equal to capital R into E by V minus 1. So in the place of E by V, you substitute over there, you will be getting R into L1 by L2 minus 1, that is equal to R into L1 minus L2 divided by L2. So if you substitute all the values here, you can able to find out the internal resistance. We know the external resistance value, that is a known resistance. So what value you are going to keep, that you can able to substitute here. And L1 L2 are find out by the two different position of the jockeys. Okay, so this is the second application of potentiometer. Okay, there are two applications. First application, we can able to find out the internal resistance. Second application, we can able to compare the EMF of two cells. Both applications are practical. Okay, and physics you have to do some project also. If they have not selected this as your practical means, you can select this as a group project. Okay, the project carries 3 marks. There you can able to use this thing. Okay, so now one more small thing is over. What is meant by potential gradient? Already we have learned about potential gradient. Potential gradient means nothing but potential divided by the distance. You know the principle of potentiometer. V is equal to IRL, okay, is equal to IRL. And here the V by L can be taken as IR, this only can be taken as K, the K we can call this potential gradient, PG, potential gradient, okay, and the unit you know that volt by meter. Okay, what is the importance of potential gradient? The potential gradient is a main factor which can able to find out the sensitivity of potentiometer. You know that potentiometer is highly sensitive device. So the sensitivity of potentiometer inversely proportional to the potential gradient. That means sensitivity inversely proportional to 1 by K. Okay, or you can write it as sensitivity inversely proportional to IR. The K only can be written as I into R. R inverse simply you can say that inversely proportional to the current I. Here R is not internal resistance, R is the resistance per unit length. So sensitivity inversely proportional to the current I. So how can we increase the sensitivity of the potentiometer? So if you want to increase the sensitivity of potentiometer, or you can write as C. One more thing also you can do, or the sensitivity inversely proportional to V by L. That means sensitivity directly proportional to L. The L will come up, so you can write the sensitivity directly proportional to L. So three important factors. Either you have to decrease the potential gradient, okay, you have to decrease the potential gradient, or you have to decrease the current. So how do you decrease the current? If you want to decrease the current means you have to increase the resistance. So your resistance must be connected in series combination with the potentiometer. If you are using a resistance in series combination with the primary circuit, then we can able to increase the sensitivity. Or third thing, we have to increase the length. You have to increase the length. So there are three different ways. The first one by decreasing the potential difference. The second one by decreasing the current or by increasing the resistance. Third one by increasing the length of the wire. So these are the length means balancing length. Instead of using 10 meters wire, if you are using 100 meters, you will be getting more sensitive. Okay, the sensitivity means nothing but even a 0.01 difference also can be measured. Correct na? So you know that you have wearing a wristwatch. Wristwatch, the sensitivity is less than the digital watch. The digital watch, the sensitivity is lesser than the watch which are used to find out the winners in the athletic meet. Correct na? There they will use a watch. There even microsecond can be recorded. So that means the small variation also can be recorded, means that we can call the sensitivity. So the sensitivity, if you want to increase, we have to use or we have to increase the balancing length. Understood? Or we should decrease the current, or we should decrease the potential gradient of the given thing. Understood? So these are about the potentiometer. Thank you, students. The second chapter, current electricity, will gets over. Now let us discuss the numericals. Let me try in a new platform the numerical. That means let us try it in Zoom class. Okay. So I will put a message in the group regarding that. You just give the feedback. Okay. Thank you. Thank you, friends.